All right, math theme. The fourth category for the first meet is number theory. There's quite a few types of problems they can give you. It could be a change of base, converting to base 10, or converting from base 10, primes and prime factors, or working with the greatest common factor or the LCM. I've prepared a couple of questions for each one. I don't think there's going to be a change of base because there was last year, 2019 and 2017, but just in case, let's say you're given the number 1234 in base 6 and you need to convert that to base 10. Well, base 10 has 1, 10, 100, and 1000 as their values of each position, and in base 6 it's 1, and then 6, and then 6 squared. So like if you had base 7, you'd have 1, 7, 49, and then 6 cubed. 6 times 6 times 6 is 216. So these are the values of each position in the number. 1 times 4 is 4. 3 times 6 is 18. So now I'm finding out what their equivalent values are in base 10 by multiplying. 2 times 36 is 72. And 1 times 216 is 216. When I add these up, I'll get what the value of this is in base 10. 10, 20, 2, 3, 10, 11, and 3. So it looks like 1234 in base 6 is 310 in base 10. You may have to convert the other way. Let's say we have the number 319 in base 10, and we need to convert it into base 6. Now, if you remember the positions for base 6, there's the 1, 6, 36, 216. So you want to build it until you get larger than this number here. And I don't know off the top of my head what 216 times 6 is, but I know it's bigger than 319. So I'm going to stop right here, and I'm going to start finding out how many times does 216 go into this? Once. And I'm going to have 103 left over. Since it goes in once, I know this number is going to be 1,000 something. Then I figure out how many times 36 can go into 103. I think just twice. It's going to be 72. And a way to check that is after I subtract, if I come out with a number larger than 36, I know I could have grabbed another 36, so to speak. So it's 2, because 2 times 36 is 72, and I got 31 for a remainder. Now that I have 31 as a remainder, 6 goes into 31 5 times with 1 left over, and so that's a 1 right there. So 319 in base 10 is 1,251 in base 6. All right, they also mentioned prime factors as a possible question. Here's one from a recent year. Find the sum of the prime factors of 3003. You got to know your divisibility rules. For 2 is if it's even, 3 is if you can add up the digits and it's multiple of 3, 5 ends in 5 or 0. Those are the easy ones. 9's pretty good, nice too, if you can add them up and divide it by 9. But this 3 plus 0 plus 0 plus 3 adds up to 6. So I know I can divide it by 3, so I divide it by 3, and I get 3 times 1001. Now I'm kind of in trouble because I don't know. I know 5 doesn't go into it, or 9, so I got to start using these other ones that are obscure. 7, 11, 13. Next prime number would be 17, 19. Could be any of these. And usually the math team questions, they do involve some of these bigger, weirder prime factors. I'm going to start with the 7. Change color for effect. I'm going to divide this by 7. 7 goes into this 1 time with 3 left over. Bring down the 0. 7 goes into 34 times with 2 left over. My mind's going faster than my mouse. Let me slow down. Cool. 7 goes into 21 3 times. That's cool because now I know 7's a factor because it went in evenly. It went in, there was no remainder. So I already know 3's a factor, and I know 7's a factor, and now I have it down to 143. Let's see if 7 can go in again. 7 goes into 14 twice, but then there's going to be a remainder of 3. So 7, I'm all done with 7. Let me try 11. So you do have 12 minutes to do the problems, and if you have the time, you can just figure this out nice and easy. 11 goes into 14 once. And nice, there's a remainder of 3. Why is that nice? Because when I bring down the 3, 11 goes into 33 3 times. Cool. So I just found that 11 goes in 13 times with no, so now I have, these are the prime factors. When they ask for the prime factors, 1 does not count as a prime factor and the number does not count as a prime factor. So all I have to do is add these numbers together. 11 and 13 is 24. 24 and 10 is 34. So the answer to this question, the sum of the prime factors is 34. Another question they said they could have, oh, this is, I thought I was going to do, I'll do this one. Find the sum of the GCF and the LCM. They mentioned that. You got to know what greatest common factor is and what the least common multiple is. To find that, I usually break the number down into its prime factors. So 36. 2 goes into 36 18 times. There's another, what's 2 times? So 18. 18 is 2 times 9, and 9 is 3 and 3. So it's 2 squared times 3 squared. That's for 36. For 45, 2 doesn't go into it, but 3 does. So 3 times 15. 15 is 3 times 5. So I break it down into its prime factors. Now, to find the least common multiple, that's where I am going to, I need to, its least common multiple is a big number. I need to have at least 2 2s, and I need to have at least 3 3s. And when I come over here, I already have the 2, did I say 3 3s? 2 2s and 2 3s. This already has 2 3s in it, so I don't have to, I need to have a 5. So for the least common multiple, it's going to be 2 times 2 times 3 times 3 times 5. I don't know if I can do that quickly. 2 times 3 is 6. 6 times 6 is 36. And 36 times 5 is 150 and 30, so 180. So right now I have 180 is the least common multiple. The greatest common factor would be, what's the biggest number that goes into both? There's no 2's over here, so the 2's are out. There's 3. There's 2 3's here, and there's 2 3's here. So right now I have a 3 and another 3. And that's going to be it, because 5 is a factor here, but it's not over here. So the greatest common factor is 9. Between 36 and 45, the greatest common factor is 9. The least common multiple was 180. It says find the sum, so I'd add those together and get 189 is the answer to that question. And one other question I wanted us to try in this video was, how many integers divide 48 with a remainder of 0? So it's just asking for, it's not asking for factors, so I can include 1 times 48. If the number is small enough, you can just go through it one at a time. 2 goes into it, yes, 2 times 24. 3 goes into 48, yes it does, 3 times 16. 4 goes into 48 12 times. 5 does not. 6 goes into 48. 6 times 8 is 48. 7 doesn't go in, and now when I get to 8, I've already have the 8. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors. Not 10 factors, there's 10 integers, but there's a trick. Integers can be negative, so it turns out the answer is 20, because after you figure out the positive integers, there's also the negative integers, so 20 is the answer to this question. There's just a few questions that could show up on the level 3 or the 3-point style questions in the category of number theory. Have a great day.